So today we're going to be talking about geometric sequences in series. So this is very similar to arithmetic sequences in series as we've done before, but instead of going up consistently by adding a certain number to our previous term, we're now going to be multiplying each term by a different ratio. So our A1, just as before, is the first term. R is equal to the ratio, and n is equal to the number of terms. So let's look at our first problem here. So we can see that our A1 is equal to our 4 value here. So A1 is equal to 4. We can see that this has a consistent pattern of being multiplied by 3. So we now know our R is going to be equal to 3. It's asking us in the directions to first find our formula and to then find the nth term. So after we find our formula, our nth term is going to be equal to 13. First, let's find our formula. A sub n is equal to 4 times 3 to the n minus 1. And that's the formula we're going to use. Now we can substitute 13 in for our n. So A sub 13 is equal to 4 times 3 to the 13 minus 1. A sub 13 is equal to 4 times 3 to the 12th power. And when you put this in the calculator, you get as your final answer, A sub 13 is equal to 2,125,764. Now let's move on to the next problem. So, we can see that our A1 is equal to 81. Each term is consistently being multiplied by 1/3. So that makes our R equal to 1/3. If we can see that our numbers are going down, we know that our R has to be a fraction. If our numbers are going up, then that means our R has to be greater than 1. So, we're still looking for our 13th term. But first, let's find our formula. A sub n is equal to 81 times 1/3 to the n minus 1. And this is our equation right here. Now let's use this equation to find our 13th term. So, A sub 13 is equal to 81 times 1/3 13 minus 1. This becomes A sub 13 is equal to 81 times 1/3 to the 12th. And when you put this in your calculator, you get as your answer A sub 13 is equal to 1/6,561. Now let's move on to the next one. So, find the first term if A sub 8 is equal to 8,192 and R is equal to 4. So it's telling us here that our A sub 8 is equal to 8,192, our n is equal to 8, and our R is equal to 4. So we can substitute these values into the equation that we already know. A sub n is equal to A1 R to the n minus 1. Our A sub n is going to be 8,192. We're looking for A1. We know that 4 is our R, so 4 to the 8 minus 1. We then can simplify this to get 8,192 is equal to 4 to the 7th times A1. When we divide both sides by 4 to the 7th and put this in our calculator, we get as our value of A1 to be 0.5. Now let's move on to the next one. Now we're going to be talking about geometric series. So just like we did with the arithmetic series, we're going to be looking for the sum of all of our terms. Okay, so we're no longer looking for a specific term, we're looking for the sum of all of the terms. So let's look at number 4. Find the sum of the first 7 terms of the geometric series where A1 is equal to 8 and R is equal to 2. So A1 is equal to 8, R is equal to negative 2, N is equal to 7. We can use all of these values and substitute that into our equation to figure out what the sum will be. So S sub 7 is going to be equal to 8 times 1 minus negative 2 to the 7th power over 1 minus negative 2. We could simplify this a bit to get S sub 7 is equal to 8 times 1 plus 128 over 3. Simplify a little bit more to get S sub 7 is equal to 8 times 129 over 3. And when you put this in your calculator, you get as your final answer, S sub 7 is equal to 344. Let's move on to the next problem. Find the sum of the first 6 terms of the geometric series where A1 equals 5 and R is equal to negative 1/2. So we see that A1 is equal to 5, R is equal to negative 1/2, N is equal to 6. So if we're looking for the sum, we are going to substitute all of our values into our equation that we already know. S sub N is equal to A1 times 1 minus R to the N over 1 minus R. So let's do that. S sub 6 is equal to 5 times 1 minus negative 1/2 raised to the 6th power all over 1 minus negative 1/2. When we simplify this, we get S sub 6 is equal to 5 times 1 minus 1 over 64 over 3 divided by 2, which we then get S sub 6 is equal to 10 over 3 times 63 over 64, which we then get as our final answer. S sub 6 is equal to 105 divided by 32. Now let's move on to the next problem. Infinite geometric series. The sum of a geometric series either diverges or converges. So, if the absolute value of R is greater than 1, that means it diverges. If the absolute value of R is less than 1, that means it converges. And if it converges to A1 over 1 minus R. What this means is if we have a problem that's like this, the numbers are consistently getting bigger and bigger and our geometric series is just going to go to infinity. However, if we have an R that's less than 1, it's going to converge and it's going to approach a specific number. So now let's look at these problems and see this for ourselves. So determine if the infinite geometric series converges or diverges. If it converges, what does it converge to? So let's look at this problem here. We can see that we're consistently multiplying each of our terms by 1/4. The absolute value of 1/4 is less than 1. So that means that this converges. Now the question is, what does it converge to? Well, we know our A1 is equal to 8. We know that our R is equal to 1/4. We can substitute these values in, we can get our answer. So, 8 over 1 minus 1/4 is equal to 8 over 3/4, which is equal to 32 over 3. And that's going to be our final answer. Now let's look at the next problem. We can see here that each of these numbers are consistently going up by a ratio of 2. So, absolute value of 2 is greater than 1. So this specific problem diverges, and that's all we can do. Now let's move on to the next problem. Suppose you have been hired to LCPS at a starting salary of $43,000. You expect to receive an annual increase of 3% per year. What will your salary be in your 5th year? So, we're going to use the information that our annual salary, it increases 3% per year. So we know our starting salary at A1 is going to be equal to $43,000. We know that our ratio is going to be 1.03 because remember, we're going to want to keep the value that we already have, which is where the 1 comes from, and we're going to go up by 0.03 each year. So these are our values that we need. And now it's asking us to find what our salary will be in the 5th year. So first let's find our equation. A sub n is equal to A1 r to the n minus 1. A sub n is equal to $43,000 times 1.03 to the n minus 1. This is our equation right here. Now we're going to want to substitute 5 in for our n. So A sub 5 is equal to 43,000 times 1.035 to the 5 minus 1. When you put this in your calculator, you get as your final answer, A sub 5 is equal to 48,396.88. So your final answer is going to be $48,396.88. Now let's move on to the next problem. A new piece of equipment costs a company $15,000. Each year, for tax purposes, the company depreciates the value by 15%. What should the company give the equipment after 5 years? Very similar to the problem we had before. We still are going to be using the equation A sub n is equal to A1 times r to the n minus 1. Our A sub 1 is equal to 15,000, and our r is going to be equal to 0.85. Since our equipment is depreciating 15% each year, we start with 1 and it's going down by 0.15 each year. So our next term is going to be 0.85 of what our original term was. Now let's find what our new piece of equipment will cost after 5 years. So A sub n is equal to 15,000 times 0.85 to the n minus 1. This is our equation, and we're now going to substitute in for n 5. A sub 5 is equal to 15,000 times 0.85 to the 5 minus 1. A sub 5 is equal to 15,000 times 0.85 to the 4th. When you put this in your calculator, you get as your final answer A sub 5 is equal to 7,830.09. So your final answer is going to be $7,830.09. Initially, a pendulum swings through an arc of 18 inches. On each successive swing, the length of the arc is 98% of the previous swing. What will the length of the arc be after the nth swing? So this problem's very slightly different. While we start at 18 inches, it's not including that as a swing. So we know our original equation is A sub n is equal to A1 times r to the n minus 1. However, we're not going to include our n minus 1 in this equation since we're not including the original 18 inches. So our new equation is going to be A sub n is equal to A1 times r to the nth power. This is just special for this problem since the 18 inches isn't included as a term. So, when we substitute our values in, we know A sub 1 is equal to 18, and we know r is equal to 0.98. When we substitute these values in, we get A sub n is equal to 18 times 0.98 to the nth power. And that is our final answer. What will the length of the arc be after the 10th swing? We're going to use this equation here, and we're simply going to substitute in 10. A sub 10 is equal to 18 times 0.98 to the 10th power. When we put this in our calculator, we get as our final answer a sub 10 is equal to 14.71 inches. After 15 swings, what total distance will the pendulum have swung? So we're going to use our summation formula. So S sub 15 is equal to 18 times 1 minus 0.98 to the 15th power divided by 1 minus 0.98. When we simplify this a bit, we get S sub 15 is equal to 18 times 1 minus 0.98 to the 15th power divided by 0.02. When you put this in your calculator, you get S sub 15 is equal to 235.29 inches. When it stops, what total distance will the pendulum have swung? So this is what we have to figure out where it converges. So eventually this is going to converge and it's going to stop. So we need to use the convergence formula A1 over 1 minus R. We know our A1 is 18 over 1 minus, and our R is 0.98. We simplify this to be 18 over 0.02, and we get as our final answer 900.